Hey, what's up, guys? This is Chung here. So today, 1,798 maximum number of consecutive values you can make. So you're given like an integer array coins of length n, right? Which represents n coins that you own, and you have a value for each coin, right? And your task is to make some value x, right? And by choosing some of the coins, and we need to return the maximum number of consecutive integer values that you can make with your coin starting from and including 0. Right? Note that you may have multiple coins of the same value. So what does this one mean? It means that, let's say, for example, we have two coins. So the first one is 1, value 1, second one is 3, right? So the output is 2. So basically we're trying to make the consecutive values from 0 to what? To the sum of coins, right? To the sum of coins, which is a total. So for this one, so 0 is always like empty one, right? And 1 means that we can make 1, right? But here we have to stop at 1 because there's no way we can make 2, right? Because to make 2 we need 2 ones, but we don't have that. That's why we have the answer equals to 2 here. And then for the second example, right, the output is 8, right? Which means that we have 0, we have 1, 2, 3 with 3 ones, and then we have 4, right? And then we have 5, 6, 7. Basically, so this one basically we can make the x for all the possible values, right? And same thing for 3 here, right? We also have it's 20. And here's the constraint, right? We have basically 10 to the power of 5, almost that, right? Yeah. I mean, at the beginning, when you look at this problem, you may think of, okay, maybe I can use this is like a knapsack problem, right? Basically, I try all the possible, I try all the consecutive target values, and then I use the knapsack problem uh, to solve each target x, and then we stop whenever we couldn't make that, right? But with the given constraints, right? I mean, the typical knapsack problem, this is like basically a 0, 1 knapsack problem. It's an n square time complexity, right? For that itself, it may already have TLE, but since we have to try all the possible x, right, that will definitely TLE. So the DP is not a option here. So we have to find another solution, right? I mean, if you watch this closely, actually, I think it shouldn't be that hard to realize that, when we try to try to make this x, right, we should use the value from the smallest, right, to the biggest, just like what we're doing here for the example 2 here, right? Actually, for the example 3 here, if we sort these numbers here, we have 1, 1, 3, 4, and 10. If we sort this value, and if we try to make this this x from the smallest to the biggest, right? Then we can see that, okay, so when x equals to 1, we can make that, right? So we're at 1 here, and then we're at when we're trying to make 2, okay, so we're also at 2 here, so we can make that. And then the next one is 3, right? So the 3 is also possible because from 1, 1, and then the next one is 3, and then from 3 the next one is 4, right? So but here we have another 4 here, right? Which means this is also possible. But I think one thing we have to be careful, and we need to make pay actual attention is that, let's say we can make 3 with the current values. So basically the total value is what? Total at this time equals to 5. right? So which means that, actually whenever we are sure that we can make a values 3 plus here, 1 plus 1 plus 3 is 5. So which means that at this position, right, we can make all the possible x from 0 to 5. Because, we are making 1 here, we're making 2 here, and now here we're making 3, right? But with 3 here, and then we have 4. 4 means that it's like 3 plus 1. 5 means 3 plus 2 ones, right? And then the next thing is here, right? Next thing is here. So can we use this number, right, to expand our x? The answer is yes, because we already have 5 previously, right? And the 5 is greater than this 4, right? Actually, it's 5 plus 1 is either equal or greater than this 4, because to be able to reach this the next number, or to be able to use the next number, we need to check the current total plus 1 if it's greater or equal than the next number, right? If it is, then we know, okay, we can use this number. So now we have 5 plus, so now the total becomes what? Becomes to 5 plus 4, which is 9. So which means that, from 0 to 9, we can make any of the x. Well, we can make any x from 0 to 9. I think it's also easier to prove, right? Because, now we have 4 here, right? And then to make 5, so we have we have 5 here, right? And then for 6, right? So for 6, we can simply use this 4 plus this 2, right? And then so this is no, this is because, from 4, right? We already know that this is similar like a DP here, because at this 4 here, we already know that, for the previously 5 numbers, we can make any number from 0 to 5, and then plus this 4. Okay, so it means that, we can make any number from 5 plus this 4, right? And then if we keep going, right, so now we check if 9 plus 1 is either equal or greater than 10, right? So the answer is yes, right? That's why, we have 19 in the end. And then we do a plus 1 to count this 0 case. So, and for the first one, let's say we have 1 3 here, right? Or we have 1 1 1 4. So in this case, we can make 1 and we can make 2, right? So if we use this formula here, so the current total is 2, right? And the next one is 3. We're targeting at 3 here, but the number here is 4, right? Which means which means 2 plus 1 is smaller than 4. So this means that we'll never be able to reach 4, because there's not enough numbers for us to use. Yeah, cool. I think that's the basic idea here, so which means that, we simply need to sort the numbers, so sort the coins, right? And then we're gonna have like a total equals to 0, right? So for coin in the enumerate, sorry, in coins, right? Basically, I simply do this. So if the total plus 1, right, is smaller than the current coin, right, then I simply break, right? Otherwise, I do a total plus C. I accumulate the total, right? And in the end, I return the total plus 1. So that's basically the idea here. Okay, if I run the code here, accept it. Okay. Yeah. So I mean, the time complexity, obviously, this one is n log n, right? Because we need to sort. That's n log n. Yeah, I don't know what else I can say for this problem. You know, you just need to be able to figure out, okay, we want to try the numbers from the smallest to the greatest, which means it's like a greedy approach. I would say that. And basically, we tried each number, right? And as long as we can reach the next numbers by using the previously known numbers, then we know that we can make all the x from 0 to the current total, right? And we just follow this kind of approach, and then we stop whenever we cannot expand the x, right? Cool. Yeah, I think that's everything I want to talk about for this problem. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.